Alright, we're going to start with the next section, 1.4, and it's called as coterminal angles. Let's first write down the definition and then I will explain what it actually means, what the coterminal actually means. So angles that have the same initial side and the same terminal side, terminal side, but are different measures. So how is it possible for two angles that have the same terminals for the same initial side and the same terminal side but have different measure? That's the key. How is that possible? It's possible because we are looking at a circle. So a particular angle goes around. So if you are given a particular angle, you can go around the circle one time and come back to the same spot. So for example, let's say I'm looking at this coordinate plane, and let's say I'm looking at an angle in the second quadrant. So that's here. So let's say it's something like this. Maybe it's 120 degrees angle. So this is called as my theta. So this is my initial side and this is my terminal side. But I can land up with the same initial side and the terminal side if I go around the circle more than once. So I start from this initial side, I go around the circle 360 or 2 pi or whatever, depending on whether you're measuring in radians or degrees, and then I land at the same spot. So this will be theta plus 360 degrees. Let's say this is 120, so 120 plus 360, whatever that is my positive coterminal. I can also have negative coterminal. How? I can start at the same initial side, which is what it says, and have the same terminal side but move in the negative direction. So this initial side, so this gives me a negative coterminal. How do we calculate this? And that's what we're going to look at, a couple of formulas to see that. So it says for degrees, for us to be able to calculate those coterminal angles, for degrees, to find coterminal angles, you add or subtract 360 degrees. So for this, I went around the circle one more time beyond this to get me a coterminal. But if you're measuring in radians, remember, one circle is 2 pi, right? 360 is 2 pi. So you add or subtract 2 pi. So you add or subtract 360 and you add or subtract 2 pi. Why do you add or subtract? Because you'll see why. Because first of all, we want a positive coterminal and a negative coterminal. And sometimes you might have to go around the circle or go back. So we'll see that. We'll see as I explain it with some numbers rather than just talk abstract. So if I want to write this down as a formula, my formula is going to be, if you're given in terms of degree, whatever angle they give you, that's this angle, plus or minus 360 degrees times k. K is what? K is an integer. K is an integer, 1, 2, 3, whatever. Why do I have this? Because you can go around the circle, remember, more than once. So if I go around the circle twice, you're adding 720. If you're going around the circle thrice, you're adding 1080, because 360 times 3. And then if you're measuring in radians, it's the same theta. This theta is given to you in radians, like a 3 pi or 4 or whatever, plus or minus, and then you're adding 2 pi, and then you're adding it, multiplying it by a k, because k is basically, so if you're going around the circle twice, you're doing 4 pi, and so on and so forth. Okay, so let's look at this with some exercise problems, and hopefully you'll get clearer with that. It says, so the question is, they've asked us for find one positive and one negative coterminal angle for each in the standard position, that is between 0 and 360, or between 0 and 2 pi for a radian angle. So let's look at this. So 0 degrees is easy. 0 is basically, if I just look at the formula, it's 0 theta is 0 degrees plus or minus 360, right? That's what I'll write. So my first one will be, sorry, why am I writing theta is 0 plus 360, 0 degrees plus 360 is 360 degrees, and then I look at 0 degrees minus 360, so it's a negative 360. So these are my positive and negative coterminal angle for 0 degrees. Now let's look at the next one. So 60 degrees is my theta, so 60 still degrees, so plus or minus, I still do 360 degrees times k. But I don't need k. Normally you start off with 1 and then you see. So let's do the first one. 60 plus 360. Both are degrees. You always have to put the degree sign. And there you get 420 degrees. And then if you do 60 minus 360, both in degrees, you get negative 300 degrees. So I got one positive coterminal, one negative coterminal. Okay, let's keep going. So 7 pi over 4. Now I'm measuring in radian. So what do? You do theta, which is 7 pi over 4, plus or minus 2 pi. Because there's more space here, I'm not sure why I'm crunching it up. Okay, so 7 pi over 4 plus 2 pi. So instead of 2 pi, I'm going to write as, you want 4 as the denominator, you multiply top and bottom by 4, so you actually write it as 8 pi over 4, and that gives me 15 pi over 4. And then for me to find the negative coterminal, let me see if this works. Sometimes it doesn't work when you do, sometimes you might have to use a k, but let's see if this works without me having to use a k. Minus 8 pi over 4, yes, I get a negative pi over 4, so I get a negative coterminal. So this has worked. So this is 15 pi over 4 and negative pi over 4. Okay, now let's look at 880. 880 is a little tricky. So 880 degrees plus or minus 360 times k. The problem is when I do 880 plus 360, I get something in the thousand something. If I do minus 360, I still get a positive coterminal. The reason is because where does 880 fall? How many times around the circle? So if I go around the circle once, it's 360. If I go around the circle twice, it's 720. And then after 720, I travel how much? So basically 880 minus 720, both in degrees, will give me 160 degrees. So that is my positive. So if I travel 160 degrees, that's in the third quadrant. This is 160, or it's also 880 degrees. So basically all I did was minus. So you have to kind of play around with it a little bit. So for me to get a first positive coterminal, I'm subtracting from 720. So how do I get a negative one? Because even when I subtract from 720, I'm getting a positive. So what if I subtract from when k equals 3? So 880 degrees minus 360 times 3 is 1080. And this will give me negative 200 degrees. And that is, one of them is a positive coterminal, the other one is a negative coterminal. Okay, I'm going to keep going. There are 3 more problems at the bottom. Let's look at all of them, all 3 of them. So 7 pi over 6 theta plus or minus 2 pi. So I do 7 pi over 6 plus, let me try the plus. Remember, you want the same denominator. So you multiply top and bottom with 6, you get 12 pi. So that gives you 19 pi over 6. That is my positive coterminal. And I subtract 7 from 12, I get negative 5 pi. So it looks like I'll also get my negative without really having to play around with k more than 1. Negative 5 pi over 6. Okay, let's keep going. And sorry, my lines are not straight, it's crooked angles. So this is going to be negative, so it's a negative angle, so but still we should be able to use the same formula. Plus or minus 360 times k. Okay, let's try when k equals 1, and let's try adding. Negative 415 plus 360. When I do this, I actually get a negative coterminal angle. So how do I get a positive? So what if I do negative 415 plus 720? I make k to be 2. So these are things you have to play around when this is negative or it's more than 360. And here I get 305 degrees. So this is my positive, this is my negative. Alright, here I'm using k equals 2. And that's how I got that. And then the next one is going to be negative 11 pi over 4 plus or minus, it's radian, so you use 2 pi over k. And then I try with the first 2 pi, so negative 11 pi over 4 plus, let's try 2 pi with the 4 in the denominator, 4 is going to be 8 pi over 4 I'm still using k, and this actually gives me negative 3 pi over 4. So I need a positive coterminal. But if I do negative here, negative 11 pi, negative 8 will give me negative 19 pi. That's still going to be a negative. So for me to get positive, let me try something else. Negative 11 pi over 4. What if I multiply this with 2? So that becomes 16 pi over 4. 4 pi basically, 2 pi times 4. And this will actually give me a positive 11. 16 minus 11 is 5 pi, and it's positive 5 pi. So like I said, you have to play around with it, because if I had done negative 11 pi over 4, what did I say, minus 8 pi over 4, I would have still got a negative 19 pi over 4. It's again a negative coterminal. I already have a negative coterminal, so I don't need one more. So instead of that, I do plus 2 pi, and then I get a 5 pi over 4. Alright, we will stop for this particular page.